My man
Hey
Dominic.
man, how you doing?
Doing well. How are you?
Not too bad. I'm excited for this one.
Yeah, midweek, talking about event-driven systems, I hear. That's what we're into. Awesome.
Yeah.
Cool. Cool. I'm hoping that you'll help me out by defining this a little bit more because I think I get a little bit confused or at least lost in the dialogue around event-driven systems because basically that's a huge it's just such a forgive me, I've got Google Calendar notifications going off. It's like super broad category, right? And it feels like, well, if I click a button on a UI, that's an event. But if there's some schedule running and it does something, that could also be an event. And so I don't know where to necessarily draw the line of what we mean by event driven, you know?
I am 100% with you, and I really enjoy talking about event-driven systems because that topic just gives me a chance to rant for a while.
Sweet.
And I just share your frustration. So um, event-driven is a topic that for a lot of us in the software engineering ecosystem, it's like honey for the bees. We are drawn to this topic. Yeah. There's like every blog post that says event driven, they're going to read it. Every YouTube video that says event driven, they're going to watch it. Well, probably not every video because there's really a lot of videos, but also every conference. If a track has event driven in the title, I'm going to be in there, and there's a lot of other people in there. So it's like the topic of event driven has a huge draw. But unfortunately, every single time, it's like I read that blog post, I watch that video, and I go to that conference talk. Of course, I learn a little, but also my frustration is growing, right? So like every single time, my frustration is growing because yet again, I don't really know what an event-driven system is. Yet again, I don't know where the boundaries of an event-driven system are and where they stop. Yet again, I don't even know what an event is. Yeah. And then it's like eventually I was just fed up with the situation. And whenever I feel um, some sort of like uncertainty, then I try to look to, for example, papers like academic papers, right? Formal models of a topic, because they usually cut through uncertainty, right? There's like sometimes they are on the complicated side, but they're always on the um, definite side, right? So they give a definite definition of the topic of discourse, right? Unfortunately, for event-driven systems, there is actually not that much. I did a lot of research, and it's like just search. Basically, I looked for a lot of like papers for formal models. There's really not that much. There's
Hmm.
not like the canonical paper that says this is a formal model of an event-driven system. These are the parts, right? This is how the parts interact. Um, so then eventually I basically just started building up my own because it's like just for the lack of readily available material and for the abundance of my frustration, that I was like, all right, and it's like with not claiming that this is the end all be all or that this will be the definitive guide, but I figured I started build my own model, my own mental model, my own formal model, so I have something to work off of, and then basically start asking questions and explore possibilities from there.
Cool. Sounds like there might be some math involved.
Very little though, very little. We don't want to go down that path. Yeah?
Maybe some diagramming. Okay, good.
Today we do math. Yeah, it's like, but it's like very, very little though. But yeah, so the first thing is basically event-driven systems, right? So or event-driven architecture. The first question is like, what's an event? Yeah?
Yeah.
And this is basically where I enter the rent. Yeah. So it's like I don't know what's an event, right? So then it's like, okay, it's an occurrence at a point in time. Okay, yeah. But then it's often like, oh, it's an occurrence of a point in time with like business meaning. I was like, you just made the situation worse. Now I don't know what an event is. Yeah, so I have to figure out what an event is, and I have to figure out what business meaning is. Yeah. So obviously the one example we all get like hit over the head with is your credit card was charged, right? So, and then it's like, okay, I can see how that's a business, that has business meaning for whatever we agree on what business means, but it's probably, yeah, most people will say that has business meaning. But just as you said, right? So it's like, but what about the button click? What about the keyboard key was pressed, right? It's like, does that have a business meaning? It's like, I think most of us will say no, right? Unless we now say, well, it's basically business. It's a domain. It depends on your domain. Well, if you're now talking about the domain of the keyboard and the domain of the graphical user interface, right? But now it kind of became like a tautology again, right? It's like, okay, yeah. So an event is an occurrence in a domain, and the domain is whatever you're looking at. So it's like, okay. So then it's like, it kind of lost its meaning again, right? So I cannot even grasp the very first step of event-driven architecture when I can't grasp event, right? And then usually we say something to the effect like, oh, we're listening to events and then we're reacting to events.
Yeah.
Right? But again, we do that basically all that time, right? So it's like we fire up a terminal, we hit the key on the keyboard, right? And something happens. Clearly something's reacting to that event. Right? So it is kind of hard to draw the boundaries. So then it's like, all right, let's start from the very, very like beginning with a minimal model of computation. Yeah? And then let's see if we can extend that to event-driven architectures. And from there, then look at like the different variations of event-driven architectures, and then also like ask questions, right? So ask questions around event-driven architectures. So, and let me just share my screen here real quick, and we do something like super simple.
All right.
Okay, can you see my screen?
Got it.
Awesome. All right. So we're gonna use something. We're gonna use lambda calculus. So lambda calculus is a universal model of computation. It's absolutely minimal. Yeah? It's based on function abstraction, which basically is function definition, and function application, which is basically function invocation. Right? So let's define a lambda calculus. Okay, so the minimal lambda calculus doesn't have much, actually. It has a variable. It has let me actually copy the lambda here, because otherwise I don't know how to get that symbol. There we go. Gonna keep that in the clipboard for a while. It has function abstraction. So that's defining a function. And then it has function application.
Can you magnify your screen just a little bit?
I actually don't know how
Okay.
on this one. Let me see. Zoom in.
Perfect.
I do it one more time because we actually don't need that much. Okay, cool. So what does this all mean? Yeah? And oddly enough, yeah, it's like this is a Turing complete model of computation. How do you express a computation in it? I wouldn't know. It's like it's like, how would you program with this? I wouldn't really know. Yeah. So turns out that's actually not that important. Yeah? So what I saw in a lot of papers that use lambda calculus as a basis, yeah? They extend the lambda calculus to basically just say, okay, we have the lambda calculus. That's a model of computation, and it gives me like functions, and I can invoke a function, right? So all good. But now on top of that, we want to do more stuff. We want to define more stuff. So that's basically what we're doing. We're not going to use this much, right? This is all there is to it. We're gonna add one more component that's a constant. This, I don't know why it adds the period. So, and then we say this is a basic model of computation, and now we want to extend it. All right, we want to extend it so that we can start talking about event-driven systems. Now, you know what's cool? Let's define what is an event. All right, and I extend the lambda calculus by a new primitive, okay? And I say raise. So that basically raises an event. And you know, now we basically have a definition of what an event is. Anything that I throw into raise, a constant, right? It's like 1, 2, 3, whatever constant. Anything I throw into raise becomes an event. So this is how you basically turn data into an event. And that makes it so graspable for me, yeah? Because now there is not the question of the nature of what constitutes an event, what doesn't constitute an event. Whatever is raised is an event. That's it, all right? End of story. That makes it super simple for me to reason about, like, now the event-driven systems. And we do one more thing. Because event-driven systems, we generally say event-driven systems, they react to events, right? So we gotta give it an event handler, basically. So what we're gonna do, right? We give it another primitive, the registration. And there, there's like a first little mini realization we're having now, right? It's like, okay, so we have an event handler. We need to register the event handler for events, but how are we going to do that, right? So an event is whatever happens on raise, right? How do we register an event handler for it? We don't have the event. Yeah? The point being that you register the event handler previously, right? And afterwards, when an event that matches the event handler comes in, you want to call the event handler. What does this match mean, right? In that case, we make it simple for ourselves. We basically just say we have a predicate function and a handler function. Right? If the predicate function returns anything non-nil, that means handle this event, right? So if the first function basically returns a truthy value, right? Call the second function or invoke the second function. The second function is the actual handler. Now we're super flexible. We can either look at, for example, something that constitutes an event type, right? Or we can look at any other. So the event type would be, for example, this is like payment received, right? Then we can register an event handler for the payment received, and or we look at any other combination of properties on the event. Right? So this is now totally up to us. right? How we define the predicates, and that is one of the defining criteria for your particular like event oriented or event driven framework, right? How can you register an event handler? And we'll get to that in just a moment. And yeah, now we can basically, we don't have to go into the details here. I have a newsletter out on the Weekend Read, one issue of the Weekend Read. Let me double check which one. Issue 40 of the Weekend Read of 2024. There, I dive a little bit more into the details of the lambda calculus, of the event-driven lambda calculus, and then also a little bit more into the operational semantics that basically give it the semantics to the syntax we see here. But now we can start asking questions, and there are a lot of questions. So the first question is, when do we register event handlers? Are we only registering event handlers at the very beginning when the system basically like boots? Yeah? You could argue like static event handlers. Or do we register event handlers dynamically? So during the lifetime of the system, can we then still register event handlers? If we argue that everything in our event-driven system happens in an event handler, that means can an event handler register further event handlers? Or also unregister, right? So I did not show the unregister part, but that basically just deletes an event handler again. So that's the first question, right? I saw in the literature sometimes if it's static, it's called first order event driven, and if it's dynamic, it's called higher order event driven. And it seems to me that static event handlers, right, where it's like the event handlers that are there at the very beginning, they are often used for inter-service communication. And there you are listening on event types, credit card charged, right? Payment collected, the goods were shipped, right? And then other services are registered on that event type. And they, for example, send an email to the user, letting the customer know that their goods were shipped. Yeah. So, and these tend to be statically known, right? They're already there at runtime. And they're not looking at specific events, really. They're like for whole classes of events that are often simply based on types, right? For these frameworks, an event has a type and the event handler is registered on the type, the end, nothing more complex. Right? So now we have a cornerstone of like these event-driven systems across that are built on top of microservices, right? Or that built basically to glue together microservices. The event handlers are static. They're known at design time. They're known at compile time. They're known at startup time. However we wanna say. These event handlers are not registered dynamically. But there is a whole different set of event handlers, and that is registered dynamically, and that is like of a completely different nature. And we're generally not talking about that as event handlers, surprisingly. And we're not talking about that as event-driven systems. And that is, think of an HTTP request, for example. Everybody and their mom, right, when they write a JavaScript application at one point or another, they call the fetch API doing an HTTP request. What do you got to do? You have to like hand over a callback. Call me back when the result of that HTTP request comes in, right? That's an event. That's clearly an event, right? So I register my interest for the future, and in the future, when the HTTP request comes in, call the callback, which is just an event handler, right? These are dynamically registered. And they are registered for one very specific event. I don't have an event handler in my system that gets called when any HTTP request comes back, right? So we are not registering these event handlers on the event type HTTP response received. No, right? We are registering these event handlers very specifically on HTTP response received for this particular request, right? And these are higher order event handlers because you register them, like you can argue the moment, or it's like if you say, but we can't do it atomically, then right before the HTTP request is actually submitted, right? So we are registering it not on a type, but basically on an ID, right?
Okay. So I think I've got a decent mental model of quote unquote lower level event handlers based off your examples of using microservices, right? And the communication between them. I think that makes a lot of sense. These higher order ones, when you talk about registering the event handler and it's dynamic, can you give me a more or use that example a little bit more? Like, yeah, what does that look like? Like, I'm imagining, because I'm imagining like somebody's, there's a function that's defined.
Yes, there is a function that is defined, and sorry, there is a function that is defined, and
which is obviously defined.
Am I sharing my screen? I'm sorry, one moment. I don't think
Not
I
yet.
do. Not yet. Okay. Still got to get used to this. Here we go. Okay. Sorry. So.
Perfect.
Okay, so let's go to that JavaScript example, right? So in JavaScript, it's like got some function, we do some stuff, and then the question is, so we just call it fetch. Yeah? Right, and then we do something with the response.
Yep.
This is a very common pattern. We actually don't need that. Let's not be too verbose, and then we could just say. Very common pattern. Now, the question is, how do we map that onto our model that we had, right? So it's like this model of like event-driven systems, that lambda calculus. Where is the register? Where is the raise, right? And so I was, because a callback is in effect an event handler, and then I was wondering how can I capture that with the same model, and that basically looks like this. So first, one way we could do it is define a new primitive that gives us a UUI, that gives us a unique identifier, right? Unique identifier, and then we can define a function fetch, right? And what would fetch do? Well, fetch takes the URL, but fetch also takes an ID, yeah, and then fetch takes a function, yeah, and we can think of it as a mental model. We can think of it that fetches a URL, right? So the contents data. Fetch gets the data, right? And fetch gets the data, and then what does fetch do as well? We can also do that first, actually. We register, right? And first we need the predicate. So we need to say, well, what do we register on, right? And well, we want to say we register to if the event ID equals that ID. Oh, that's cool, yeah. And then we good. And then what we want to do, that's basically our event handler. Yeah, what we want to do, and the event handler is the function which gets a response. So we can register our own event handler here. We get that event, and then we call that function with the event response or event. I think we call it data, event data. All right, and then at the very end, what we have to do is say raise. And we raise where the ID is that ID, and then data is data. So now we have mapped that idea of like callbacks in JavaScript to events and how to register events, and then how the runtime calls events, right? And that's now a higher order event-driven system because I am registering events during the runtime of the system. And the events are very different in the sense that, I don't know why I have that on the outside here. That was not well thought out. We can just do that in here. And I register that during the runtime of the application, and the events are just very different because they generally don't react to, right? I don't want this event handler to be called every single time I'm receiving an HTTP response, right? I want to register this particular event handler for this particular response. That's why we model it with a unique identifier here. We model it with a unique identifier. We're registering that particular callback with that unique identifier, right? And then later we raise that event with that unique identifier. And that's basically how we can reason about the fact that, oh, look, at the one hand, on this static first order kind of event-driven system, we're listening to event types. And on this dynamic higher order event-driven system, we're actually listening for event instances. And that's not a hard rule, all right? But that seems to be the common common usage pattern.
Interesting, because I can see
right?
that I feel like I can see a bit of a gray area there where you might make a generic statement saying like, well, anytime I have to make an HTTP call, that would be an event that would be of a type, right? It would be like an HTTP, you'd be doing a fetch type, but really like you want to break that down a little bit more. Sounds like, okay. I mean,
in your application, typically you want to react to one very specific response, right?
Right. Okay.
However, if you were thinking about something like, for example, how does like observability fit into that whole equation? Could I, in a runtime, register an HTTP response, a generic? I am getting an HTTP response. Absolutely, right? So that would also make sense. Yeah? So then you can argue I have a static, but it's probably static again, right? It is registered like when the app comes up, right? It's like, yes, you can argue maybe I want to like be able to turn on and turn off observability. In that case, it would be dynamic. Whereas there's also a gray area, right? So static and dynamic as terms are also really interesting because you basically have to take a certain time frame, right? I can argue I am static if over that time frame I do not change, and I'm dynamic if over that time frame I do not change. If you apply a different time frame for me, what's dynamic for me may be static for you because during this time frame it doesn't change. Yeah. So that is in and of itself dynamic and static. It's not hard and fast, right? It depends on the observer and how the observer defines the observed time frame. Super cool. It's always super cool. That's why in software engineering you always get that super frustrating answer. Well, it depends. But in a lot of situations, it's really, really true. Is it dynamic or is it static? Well, it depends. Okay. Yeah, so that was the first realization about event-driven systems. So if you use this particular mental model of event-driven, you can reason about event-driven systems in the sense of where we have these domains and the business events, and there are the event handlers that listen to like something like credit card charge, right? These are often static. They're known at runtime. It happens at the, at design time. It happens at the boundaries of the system where one service communicates with another service because that service is listening. But then within these systems, a lot of things are also event-driven on a, probably we could argue on a different level, maybe less business, more technical, but what does that even mean? But for us, like what we basically attribute to that, right? You could argue, I know business when I see business, or I know technical when I see technical, but I can tell what it is. So then within the service, there's often more the technical perspective is valid, where it's like, hey, I'm firing off an HTTP request that goes in my somewhere in my operating system. It's going to be happen asynchronously. Eventually it comes back. I want to react to it. That's a callback, and that's an event handler, right? In JavaScript, the event loop, right? That callback is registered for that event in the event loop. That's why it's called event loop, right? So there, that particular model works for the one type of system and the other type of system. And most of the time it's the same thing, right? If I write one of these event-driven systems with JavaScript, then I have to be dealing with these two different events, two different types of events.
You say these types of systems.
But what is that, right? Exactly.
Yeah, exactly. Well, it's just like that's the definition makes, like, I feel like you know, starting from your calculus and building up to that very practical example makes sense, right? And we talk about the lower order versus higher order. So now we've got some categories of events, event types, or the definition of events, if you will. But then I feel like I'm kind of back to, well, this is pretty broad then, because then,
yeah, it is broad. It's very broad.
Somebody says event systems, like, well, most I'm that would be 90 plus to closing in on 100 plus of the % of all the systems we're creating are then thus event driven.
Why? Because fundamentally distributed systems are event driven. There's like a distributed system is a collection of components that communicate over a network by exchanging messages. Receiving a message is an event. There is nothing we can do to change the nature of that. Like distributed systems on that level are event-driven systems. Now the question becomes like, okay, what is that type of event-driven system that we often talk about, right? And you're entirely correct. We only now define something like the very base of foundation of some stuff that we can use to talk about these things, but we haven't narrowed down what this event-driven system that we often talk about is. But we have too many other questions to answer still. But once you find an answer for all of these questions, there is your event-driven system, all right? The cool thing is that we tailor-made it. We tailor-made it to your situation. All right, let's ask a few questions. If multiple event handlers are registered for one event, so multiple predicates return true, will all of them be called?
Is that a it depends answer?
Exactly. Yes. Don't throw that back at me. Yes. Yeah, you're right. It depends. Yeah. So it's like, how are we building our system, right? It's like, do we have persistent events, right? Maybe, for example, something like Kafka. Yeah. Then it's like, are all registered event depends a little bit. Kafka has partitions. Now we also have to like basically think about, well, if the event showed up in that partition, that event handler would be called. But that event handler showed up in this partition, so that event handler didn't get called. However, for all intents and purposes, that event handler is the same event handler as that event handler because it's the same code, because we deployed our application twice. So yes or no? Depends on your point of view, but we can argue yes, right? But you see how we are now tailor-making our system. So that was the first question. Are all registered event handlers called? Yes, cool. Are they called at most once, at least once? Exactly once would be nice, but we can't have it. Yeah? It's like, also depends. It's like, is the underlying mechanism that basically delivers or invokes these event handlers, is that an at most once or at least one system, right? In Kafka, depending on how you do it, if you advance your high watermark first, then you call the event handler, it's an at most once. If you call your event handler first and then advance the watermark, it's an at least once. And if your event handler is idempotent, then it's still an at least once, but it has exactly one semantics. Lots of stuff. So do you want that? Is that a criteria for you to say an event handler, right, executes as if it was executing exactly once? Then you at least have to have idempotence, and even that is already like, oof, yeah. It gets very, very, like exactly once processing semantics gets very, very complicated. So we have that. There is a temporal component to that. If an event handler is already registered and the event comes in, right? But yeah, I want that event handler to be called. What if the event enters the system first and then I call the event handler? I register the event handler. Should that event handler be called now or not? That's a non-trivial question. So first off, we can say, no, I don't want that. Cool. But if we have something like Kafka or a message queue that's actually responsible for delivering these events, there is going to be a lag, right? So there is no actual guarantee. So the event already entered the system. So the event has a recording timestamp. The event already entered the system. No? But the event handler was technically registered afterwards. But now that the delay comes into play, right? Boom. From the point of view of that particular event, it looks like that event handler has always been there. Right? All right, are you going to mess around with timestamps now? We have a registration timestamp. We have a registering the event timestamp. We have a registering the event handler timestamp. Are they even comparable? Because in distributed system, timestamps not necessarily comparable, right? Now it gets really, really complicated if we want to throw around logical timestamps and see, it's like, can we link the recording of the event with the registration of that event handler? Oof, gets very, very complicated. Right? On the other side, we may even want to backtrack, right? And say, it's like, all right, I'm installing a new event handler in the system. I actually want to now process at least all credit card was charged event of the last 24 hours, right? Is that part of your system? And now we are basically tailor-making our event-driven system, what we understand of event-driven systems. Right? We are tailor-making that. And we can now draw a rough boundary, rough, yeah, because you can totally say, no, my event-driven system looks different. But we can now draw a rough boundary onto what do we generally understand when we talk about event-driven system in the context of modern applications, in the context of distributed applications, in the context of microservice oriented applications. Right? And based on that model, generally, in these systems, there's at least one component that will raise an event at some time, right? Somebody has to raise an event, otherwise there's no event in the system. So there's one component that will raise an event in that time. That event will probably have a type property, whether it's called type, whether it's called kind, but some kind of type identifier. I am of the type credit card was charged. Doesn't matter if it was Dominic's credit card or Cully's credit card, a credit card was charged. So there is this particular type. These types are known at design time. You know? And then there is at least one other component in the system that has a static registration. So also that registration is known at design time. We are registering on event types. Again, we are registering on credit card was charged. You know? And it's not Dominic's credit card was charged or Cully's credit card was charged. You know? And then we expect that every event handler that was registered, right, will be invoked at least once. And with that, we can, for example, very quickly construct this canonical example of credit card was charged, send an email to the user, right, or to the holder of the credit card. Send an email to the holder of the credit card. So that is now the very, very rough outline of what we think about when we hear event-driven systems. And from there, we can ask a lot more questions. So for example, are the events bare bones, sometimes also called anemic? Do they only have the the data necessary to identify themselves, or are they full-fledged, right? Or rich? Yeah, there's I'm not only telling you a credit card was charged, and this is the ID of the user and this is the ID of the credit card. Go look up the data in the system, in your database, while you run the event handler, if you want to get the email of the user and then send an email. Or does the event already have all of these fields, or most of the fields that most of the other event handlers need, right? Hey, that's fair game. We can totally discuss that. There's probably not one answer for one system. Some events will be anemic, yeah? Some events will be rich, yeah? Or it's bare bones and full-fledged. Yeah? So that really it depends on the team, depends on the microservice. But all of that falls into this broad category where there is at least one component that raises an event. That event has an event type. And there is at least one component that on startup or design time registers statically an event handler for events of a certain type. And that is what is the outline of event-driven systems.
I really like how you brought this back to a place where fundamentally we're operating, we're aiming for, imagine a scale, right? There's this all known behavior. We are able to completely ahead of time, completely understand and predict the behavior of a system. And then there's the scale that goes to the other end, whereas you throw in an input and you have absolutely no idea what's going to happen. And all of this talk about the patterns and desires of your event driven system, tailor making it, is trying to find the best way through architecting this a system to be as close to predictable as possible, right?
That is a very nice, that is a very, very nice property, because event driven systems are often not as predictable as, for example, imperative systems. If I have an imperative system, then it's like typically the code looks like step 1, step 2, step 3, step 4. Mm-hmm. So I look at it and I see the steps that are going to execute. But for event-driven systems, I have one event handler, and that event handler may raise more events, and then other event handlers fire, right? So it's not as localized, right? There's step 1, step 2, step 3. I just see event handler, raise event. What's going to happen? We don't know, right? So that's why oftentimes we say it's like, oh yeah, it's like they emerge. The behavior of an event-driven system emerges. But that's just a fancy word of like saying, we don't know. We have no clue. Turns out though, it's like with these event-driven systems, the more static your event handlers are, the more you know again, right? Mm-hmm. The more you can know. You still don't see it immediately reflected in code, because if in doubt, the component that raises event over here, the component that listens to event over there, may be completely different microservices done by completely different teams. You don't really see that. But the more static, right? So the first order type of system is a lot more predictable than the higher order type. It's basically unpredictable, because I can register and unregister events by definition, event handlers by definition as I want. Yeah. So it's like predictability 0. So I would definitely, in like practical terms, when we want to bring it back practical, right? When it says like, okay, figure out what your event-driven system looks like for you. What are your event semantics? What are your event registration semantics? What are your event delivery semantics? Yeah? Drag it to the side where it is known at, the more is known at design time / compile time, right? Then your system is much more predictable. Otherwise, you're chasing after the system.
Yeah.
Chasing after system behavior, obviously very, very hard.
Yeah. It occurred like a sort of this picture just started getting painted for me, sort of in terms of like within the context of predictability, how this conversation takes a lot of context is all. That's sort of like what happened to me while you were detailing that. So that was very cool.
It took me really a long time. I was hoping to find either one paper or multiple papers that basically lay out this idea of what an event-driven system is. I found some of them, but turned out they were, for example, they said, oh, what's an event-driven system? In like basically in the sense of like the Android framework for the Android operating system, right? So the Android application development framework, right? So it's like, okay, and there are certain events and there are event handlers, and then there are a few changes. I'm not an Android developer, so I don't fully remember. But they painted some nice mental models, but it was definitely not what I was looking for. For like it's like, okay, distributed systems, cloud systems, right? Microservice oriented systems. So, but on the other side, it's like, you have an event over here, you have an event over there, right? So it's like key press is an event, button click is an event. So why is it not built on like a common foundation, mental model wise, obviously not like implementation wise, but why is it not built on, and what would that be? One raises an event and the other raises an event. One listens to an event, basically like invoking an event handler. The other one listens to an event, invoking an event handler. So eventually then, it took a very long time now. It took a very, very long time. And eventually I was like, I did this like my own Lambda calculus for being able to reason about it and just ask the question. It's like, hey, when is the event consumed? When is the event consumed? If it's consumed, it's not available for other event handlers anymore, right? It's like registration before raising, raising before registration, at least once, at most once. So you can ask yourself a lot of questions if you have this like minimal building blocks, mental building blocks. And then eventually you can basically draw an outline, because none of these questions can be asked, can be answered definitively, right? It depends on your application. So, and it depends on your decisions. It depends on your technology stack, right? So it's like Kafka has obviously different guarantees than when I send events via TCP. Yeah? So then it's like I was trying to find these fundamental building blocks, and then what are like the not minimum requirements, that's not right, but what we, most of us, when you look at all of the blog posts, all of the videos, right, all of the conference talks, what is like a theme, whether it's like explicitly stated or just implicitly there? It turns out at least one component needs to raise an event. At least one component needs to be listening for that event, has an event handler registered. The events typically have event types, right? The ones that are raised and then the ones that listen. So that you are listening for multiple instances, not just one instance. An HTTP callback listens for one instance. It will be called once, typically, right? But this credit card charge will be called n times for n credit card charged events. And so now you can argue, man, but there are so many systems that fall under this. But
Yeah.
it's true. It is still a very, very broad category, right? But it does give you a starting point where you say, all right, in or out, right? So if a system, for example, doesn't raise an event of that quality, right? And the system doesn't raise an event of that quality, you can argue it's not an event-driven system. Right? If you never raise that event, like credit card charged, right? Never event of that quality, where it's like you're raising an event of a certain type and other pieces of the system listening to an event of a certain type, you can very well argue this is not an event-driven system the way we generally think about it in the context of modern cloud applications, modern microservice-oriented applications. The fact that there is an event handler registered just simply on an HTTP call, right? For the HTTP, for the callback, for the response, doesn't count. We generally do not say that that's not what event-driven is.
Would you say it's worthwhile to continue classifying systems using event-driven terminology? It just sounds like it's such a sort of buzzy, almost
It's buzzy.
marketing.
It's no question, it's buzzy.
Right, like term that it doesn't add a whole based off of this like deep dive into defining, categorizing, asking these questions. It's still so broad. It's still so like I feel like I've got a better handle on it now than I ever have, and it's still quite like not a lot to grab onto. Like, what would I don't know if there's like an alternative, but it sounds
no,
like
it's worth it.
Yeah?
It's worth it because it has consequences. Yeah?
Okay.
And that is, for example, again, it's the locality principle is broken. If I have, for example, an imperative style laid out workflow, step 1, step 2, step 3, I know what is going to happen. If I raise an event, I do not know, right? So it's like other components in the system may or may listen to it. I probably don't know. Over time, system evolve, new components come in. I don't know, right? Are they now going to listen to that event or not? I don't know. If I have to change step 1, step 2, step 3, step 4, add a step 5, I know that, right? If now some other system, some other component in the system reacts to that particular event, I don't know. So it has real consequences. A negative consequence is event orchestration, which is a totally different talk. There's there's orchestration choreography, so event choreography. So that's a totally different talk. It's a totally different topic. We can look into that. What's orchestration? What's choreography? Right?
But it sounds like. I was just to say, but it sounds like it has consequences because we're also assuming distributed systems.
Yes.
Right. And that's the key here is like assume distributed, therefore event driven has consequences.
Yes. Yeah. If you have a single node system, it's much easier to handle all of that.
Right.
Much easier. Yeah? You can basically do, if necessary, you can do a as simple as find, right? And it's like, okay, where am I listening to these kind of events? Right?
Yeah.
So, and in a distributed system, I just can't. Right? So it's like, maybe if you have mono repo and whatnot, but it's getting complex, right? Yeah. So, but yes, if you have as soon as you have the ability in your system to raise an event of a type, and some other component has the ability to register its interest in that event type, right? That has consequences. They need to be managed.
Word.
Okay. And so it is a valid category because it's like, if you don't have that in your system, you don't have these particular concerns.
I think, yeah, I think I appreciate it. My mental model is very much stronger, from this conversation, and that's usually valuable for me. If anybody else is watching this and they get that out of it, I hope so too.
Oh, me too. It's like it always helps me so much if I reduce something to the very essence of it, right? And if you think about it, it's like now we can reason about distributed systems by the event-driven systems by the essence of it. If we say the essence is raise and register, it's like, whoa, yeah. And then it's like, okay, what kind of events constitute, what kind of event handlers constitute an event-driven system for most of us in our heads, right? And it's just super cool. The moment I crossed that threshold, I was actually really happy about it, because I can see that like most blog posts, most conference talks, I went in there and I always learned something. Yeah, but it's like, because like, how do you structure your events? Yeah, and it's like, what is good architecture, what a bad architecture. I always learn something good about the opportunity, about the mental models of the authors and conference speakers, right? There's always something to learn from others. But I was still super frustrated that every single time I came out there and it's like, I still don't know what exactly an event-driven system is. And it's like, now I can point to it, raise and register. Boom. Yeah, love it.
Very cool. Well, as always, I appreciate your expertise. It's fabulous and well.
No, thank you.
And always the deep journey into thought. So thanks for not letting me down there.
Hey, thank you very much. Yeah, I'm looking forward to the next one.
Awesome, man. Cool. Well, it sounds like we've been at it for about an hour. Sounds like we're at a good spot to wrap it up. Anything else we wanted to share before we conclude today? Let's see here.
I'd say if anybody wants to chat about event-driven systems, join our Discord, and then we keep the conversation going. And if not, but you still want to read up a little bit on it, my newsletter, The Weekend Read, issue number 40, talks about event-driven systems and the event-driven lambda calculus, and also dives a little deeper into the operational semantics.
Awesome. Well, I'll be looking forward to checking those out myself.
Cool,
man. Awesome. Well,
thank you very much.
Have a great Wednesday.
Yeah, you too. Talk to you soon.